So this video is an attempt at the worked solutions for the S1 paper that was first released just yesterday. And this is the 2018 October paper 63. Now a little sort of addendum to this is that I don't have a mark scheme. It hasn't been released, and so there could be mistakes in this video, and I would welcome your corrections underneath. So a group consists of 5 men and 2 women. We want to find the number of different ways that the group can stand in a line if the women are not standing next to each other. Now actually, easier way to do this is to work out how many ways they would be standing next to each other, and then take it away from the total ways you could arrange these people. So if we've got 7 people, then the total ways that they could be arranged is 7 factorial. Now, if we think of the ways that the 2 women could be put next to each other and have that as a block of 2 women, we then are left with the 5 men plus the women. So that's 6 items to arrange. So that's 6 factorial. And then the 2 women, they could swap places as well. So for each of those 6 factorial ways, we can double that for the 2 ways the women could be organised. So then the total ways of arranging it with the women apart will be our total ways of arranging the 7 people, take away the total ways of having the women together, and that will come to 3,660. Now we've got a 6-sided dice, but with some unusual numbers on it, and a 3-sided spinner, and those 2 results get added together to make X. We need to do a probability distribution for X, so to do that we're going to need a sample space diagram first. So we've got a table of the possible outcomes of the dice and the spinner, and we can see that the numbers could come out from between -2 and 3. So we need to do a sample space, a probability distribution table for that. So it looks like this, where we've got all of the possibilities, and now we just need to count how many we've got of each one. So we have, in total, there's 18 possible outcomes from this sample space. And we get -2 in 2 of those. We get a -1 4 ways, 0 is 5, and so on. Now, using that probability distribution, we will be able to work out the variance of X using the formula, where we know that E of X is to do each value multiplied by its probability and add them all up. And E of X squared is doing all the same things, but squaring those X values as you do that calculation through. So then the variance of X is 11 over 16 minus 1/6, which is 5 over 3. Okay, fairly straightforward tree diagram to do now, with red and blue balls in there to begin with, so we can either have red or blue on the first ball. The important thing is it then is not replaced, but a yellow ball is put back in after that first one is taken out. So to begin with, we have 3 out of 8 on the red and 5 out of 8 on the blue. Then we could have red, yellow, or blue. If we've taken out a red, there'll be 2 reds left. There'll be 1 yellow, 5 blue. If we've taken out a blue, there'll be 3 reds left, 1 yellow, and 4 blue. Right, for 2 balls to be the same colour, they would have to be red, red, or blue, blue. So we find the probability of those and add them together. Now we want the probability that the first ball taken was red, given that the second ball was a blue. So we're restricting down to only look at the situation where we get a blue as our second ball, and we want the chance of having red out of that for the first one. So the probability of getting a blue on the second ball is 35 out of 64. No, so we have this group of 12 people. It kind of doesn't really matter that there's 8 boys and 4 girls in this situation. We are picking 7 from those 12. So first of all, if we're finding the probability that this group of 7 includes one particular boy, we need to find all the different groups of 7 that we could make. Then we want the number of ways that would include this one particular boy, plus 6 people to make up the rest of the group. So choosing that 6, we've got 11 left to choose from. So that comes to 462. So the probability comes to 7/12. So for this one, we need to consider the probability that the group of 7 has at least 2 girls. We need to separately think about there being 2 girls, 3 girls, or 4 girls, and then adding up those different ways of making those groups. So for the group that has 2 girls, we would choose 2 girls from the 4, and then we would put the rest of the group being boys. So multiply that by 8, choose. Now we've chosen 2 out of the 7, so we've got 5 left to pick. Next, we want to look at groups that would have 3 girls in them. And similarly, we're going to do 4 choose 3 times 8 choose 4. And that comes to a total of 672 groups that would have at least 2 girls. Then express that as a probability, and it'll be 672 out of the total ways we could make a group of 7, which comes to 0.848. Question 5 is about a normal distribution to do with the weights of apples. We want the probability of medium, which means that it's between 90 and 140 grams. So standardize that for Z, take off the mean, divide by the standard deviation. And that gives us a final answer of 0.6919, which we've been asked to give it to 3 significant figures, so we'll go 0.692. Okay, so we've got 4 randomly chosen apples. We want to find the probability that at least 2 of them are medium. So we have x being our number of apples that end up being medium. They will follow a binomial distribution where we have 4 trials, and our probability of them being medium is what we just worked out in the previous question, 0.6919, which I suppose that probably let you use 3 significant figures, but I'm going to keep it as 4 just to be as accurate as possible. So the probability that x is at least 2 is 1 minus the probability that x is less than or equal to 1. So that's 1 minus probability that x is equal to 1 plus the probability that x is equal to 0 and equal to 1. And that comes out to 0.91023 significant figures. Okay, so we've got another normal distribution question. This time we're going to work backwards to work out sigma. So the probability it lasts more than 1800 hours is 0.96, with the mean being 2000. Just to make it easier, so that we're looking at a left-hand tail, I'm going to reflect that round, use the symmetry of the curve. So if I take that same bit but over this side, that 0.96 on the other side would be evenly distributed. Now, since that's a gap of 200 on the left-hand side, it'll be 200 here as well. So that value there will be 2200. Use the standardizing to turn that into Z. Reading backwards off our table, we can see that 5 1.71 would give us an answer of 0.96. And I just realized I had put 1800 instead of 2000, so I've just replaced those as the means, which gives us the standard deviation when we solve that equation of 208.3 hours. So we've got a binomial distribution here where x is the number of light bulbs that last more than 2,500. So that'll follow a binomial distribution. We've selected 300 of them, and the chance that they last more than 2,500 hours is 1 in 5. We want to work out the probability that x is less than 70, so 70 of these last less than 2,500 in our selection of 300. We don't want to use a binomial to do that, it would take far too long, so we will approximate this with a normal distribution. Okay, so putting in NP and NPQ for our normal approximation, we can see that they are big enough to be able to do this approximation. So now we need to add a continuity correction, so we want the probability that x will be less than it's not less than or equal to 70. We've got to undercook the approximation, so it needs to go to 69.5, take half off, so that 70 does not get included. Okay, so now standardizing. That comes to phi of 1.371, which is 0.9149. So I did briefly mention the justification when we considered doing the approximation just now. We'll just put it formally. So NP and NPQ are both greater than 5. The mean and variance are large enough to justify the use of the normal distribution as an approximation to the binomial one we were given. Right, stem and leaf diagram seems easy enough. Make sure you've put all of your numbers in numerical order after you've put them onto the right stem, and that you have a key. And since it's a back-to-back one, I've actually put a key for both ways round just to be sure. Okay, so we need the median and the quartiles for the anvils. So that's on the left-hand side. So we want the one that's in the middle. We've got 11 pieces of data there. 1, 2, 3, 4, 5, 6. So we have, oh no, hold on. It'll be, this one here is the median. We've got 5 on each side of that. So the median for the anvils will be 173 centimeters. The lower quartile will be down here where this 9 is, so that's 169 centimeters. And the upper quartile is this one here, so it's 181 centimeters. Right, so we've got the sum of x and sum of x squared for the anvils, and then 3 members joined. So we'll have a new sum of x and x squared, and we will also get a new sum of x squared. So now we can work out the variance, or rather the standard deviation. We can just go straight to it with the formula off the formula sheet. That comes to 9.91 centimeters to 3 significant figures.